Mathematics 2, 2015 exam, question 10. Determine the following integrals. Each of these three integrals has two parts to it, so we need to use integration by parts. In case you don't remember the formula, remember that the differential of uv is equal to u dv dx plus v du dx. So we can say that u dv dx is equal to uv minus v du dx. So we're going to make one of these parts u and the other part dv dx. Question is which one? A quick rule of thumb to remember is Liate, L-I-A-T-E. L stands for logarithmic, I stands for inverse trig, A stands for algebraic, T stands for trig, and E stands for exponential. In part 1 we've got x, which is algebraic, and log x, which is logarithmic, obviously. So we're going to let log x equal u and x is equal to dv. If u equals log x, du dx is equal to 1 over x. And if dv dx is equal to x, then v is equal to x squared over 2. So I differentiate this term and I integrate this term. The integral is now equal to u v minus v du. X squared over 2 times 1 over x. One of the x's will disappear, so I'll get x over 2. Integrate x, you'll get x squared, and then you divide by the new power. So this term will turn into x squared over 4. I've got x squared over 2 in this term here, so I'll take x squared over 4 outside a bracket. So I'm going to get 2 log x. If you're not sure about that, just expand that part and you'll see that it gives you this. This term gives us minus x squared over 4, x squared over 4 times minus 1, and a constant of integration. Part 2. I is equal to the integral of x squared e to the 3x dx. So as before, we look for the terms that we're going to use first. We don't have any log terms, we don't have any inverse trig terms, we do have an algebraic term, in this case it's x squared. So we'll let u equal x squared and dv equal e to the 3x. So u equals x squared, dv equals e to the 3x, so differentiating u I'm going to get 2x, and integrating dv dx I'm going to get e to the 3x over 3. Substituting those into our equation, I'm going to get u v minus v du dx. Now we started with x squared e to the 3x, and by applying the integration by parts rule I've now got x e to the 3x, so that's reduced the power by 1. So now what I'm going to do is I'm going to take this part and call it I1. So I1 is equal to x e to the 3x. So we'll apply the rules as before. We'll let u1 equal x and dv1 dx equal e to the 3x. So du1 dx is equal to 1 and v1 is equal to e to the 3x over 3. So I1 now becomes u1 v1 minus v1 du1 dx is just 1. I can integrate this directly now. So we have I1 is equal to x e to the 3x over 3 minus e to the 3x over 9. So now I'll substitute equation 2 into equation 1, giving me minus 2/3, which is from here, and then x e to the 3x over 3 minus e to the 3x over 9. I'll take e to the 3x over 3 outside a bracket, so now I've got x squared minus 2x over 3 plus 2/9. got a minus and a minus, which is where the plus comes from, and I've got a constant of integration. Part 3. Again, we're going to do integration by parts, so let's remind ourselves about the Lie-80 rules. We don't have a logarithmic term, we don't have an inverse trig term, we don't have an algebraic term, but we do have a trig term, the sine x, so that's what our u is going to be. So let u equal sine x and dv dx equal e to the x. So du dx is equal to cos x and v is equal to e to the x. So I now becomes uv minus the integral of v du dx. Now what I'm going to do is I'm going to let this term become I1, and we'll use the same rules as we did before. So u1 becomes cos x and dv1 dx becomes e to the x. So du1 dx becomes minus sine x, remember the differential of cos is minus sine, and v1 becomes e to the x. So u1 now becomes uv minus v du, only sine was a minus, so that minus, we've got a minus times a minus, so that becomes a plus. Now e to the x sine x is where we started, so I can replace this term with I, and that's my equation 2. Now I'm going to substitute equation 2 into equation 1, so I equals e to the x sine x minus e to the x cos x plus I. If I expand this bracket, this will become minus I, and I'll take it across to the left hand side. So 2i equals e to the x bracket sine x minus cos x. So I is equal to e to the x over 2 bracket sine x minus cos x plus a constant. Part B. Evaluate the following definite integrals. Part 1 is a polynomial in x, so we can integrate that directly. So I'm going to get x cubed minus x squared plus 5x between the limits of plus 2 and minus 1. We start by replacing all the x's with 2, and then from that we subtract the result of replacing all of the x's with minus 1. So all of the x's replaced by 2 is that expression, minus all the x's replaced with minus 1 is that expression. 2 cubed is 8, 2 squared is 4, 8 minus 4 is 4, 5 times 2 is 10, so this bracket becomes 14. Minus 1 cubed is minus 1, minus 1 squared is 1, but I have a minus there, so that's minus 2. 5 times minus 1 is minus 5, so this bracket becomes minus 7. So I've got 14 minus minus 7 gives me an answer of 21. Part 2. Integrate sine x dx from 0 to 2 pi. Before we integrate, let's think about the sine curve. The sine curve looks like that, and the area of this section is equal to the area of that section. Now, areas in integration are positive when they're above the x-axis and negative when they're below the x-axis. So if we integrate sine x from 0 to 2 pi, I'm going to get 0. So instead of integrating from 0 to 2 pi, I'm going to integrate from 0 to pi over 2, which is a quarter of the whole curve, and that way I will get an area. So we can rewrite I as 4 times the integral from 0 to pi over 2 sine x dx. The integral of sine x is going to give us minus cos x between the limits of 0 and pi over 2. Cos of pi over 2, remember to use radians, is going to be 0. The cos of 0 is 1, but remember the minus here, and obviously we're subtracting. So we've got minus minus 1, which gives us plus 1 times 4 gives us an area of 4. Part 3. Integral of e to the 2x between 3 and minus 2. The integral of e to the 2x is going to be e to the 2x over 2. So that's where the half has come from. There are my limits, +3 and -2. So that's going to be a half outside e to the 6x minus e to the -4x, which gives us a value of 201.71. And that's the end of question 10.